We're back out here the next day to get some drone footage because it was raining last night. And it did snow last night. That's the backside of Red Rock. Red Rock has snow on it. Got nothing better to do, so I'm going to ramble a little bit about emissions and swaps and monitors. And it does seem like a lot of you are interested in that. I want to say that this 5.3 has really done excellent. It's hauling this heavy JK with 40s just fine. Now, back in 1981, the federal government mandated OBD1, Onboard Diagnostics 1. And what that did is it made manufacturers look for and store emissions-related trouble codes, DTCs, digital trouble codes. And for the most part, the diagnostics were off-board, which means you hooked up a scanner, you hooked up a code reader, even jumped a connector and flashed out codes. So most of the diagnostics were off-board. In 1996, when OBD2 came out, Onboard Diagnostics 2 meant that not only did they have to store this information, but the monitors were run on board. So we have multiple monitors. Most vehicles have about 9 monitors. You've got O2 sensors, even air conditioning, EGR, secondary air systems. The LSs don't have EGRs or air systems, for the most part, in the Gen 4 and 5 engines. But these monitors would run and then they would complete or set after drive cycles were completed. In the mid-90s, a lot of times these drive cycles would not complete the monitor because they were too stringent or there was a bug. And some manufacturers like Mitsubishi and Hyundai got exemptions when emissions testing because the monitors, even the dealers could not set them because the requirements were too high. Well, move on to 1996, and with Onboard Diagnostics 2, these emissions-related monitors must run and set using Mode 6 data from the US EPA. And this is where Hemis and some of the other power adders have an issue. Now, what I really want to talk about is the relationship between the network and the hardware and combined with the firmware and software. Just because you are running an OE computer doesn't mean you're going to be emissions compliant. So, when you do an engine swap, or even in a factory vehicle, what happens is the wiring is set up so that it works in conjunction with the manufacturer's certified configuration. Now, prior to OBD2, if you had a misfire, you had a misfire. Failures usually meant the vehicle went rich. The government wanted the vehicles to go lean. There was talk about running both a MAF sensor and a MAP sensor so that you can go speed density if the mass airflow sensor failed. Chrysler, for the most part, does not run mass airflow sensors. GM does. Mass airflow sensors can, in my opinion, lead to better drivability, especially when you change temperatures, altitude, your environment changes dramatically. In the 90s, on some of the fuel-injected vehicles, if you moved more than 4,000 or 5,000 feet, you had to shut off the engine so the baro could reset to the new altitude and then get going again. The MAF doesn't have those restrictions, or at least is not as much. In addition, now the new Gen 5s are running humidity sensors, temperature sensors, and airflow sensors. So they're very precise as far as barometric pressure and airflow through the intake, density, air density. So let's go back, and in 1996, the federal government required misfire monitoring. This meant that they had to identify each individual cylinder. Prior to that, if you had continuous fuel injection or electronic fuel injection, continuous fuel injection, essentially you were just pulsing the injector or changing the pressure to get the vehicle to stoichiometric or react to a feedback O2 sensor. In 1996, OBD2 required that top dead center or a cam sensor be installed so that the computer could identify which cylinder has the issue, and then it could shut off fuel to that injector so that you're not polluting. Now, you probably noticed that if you are gross polluting or in jeopardy of damaging the cat, the check engine light will flash. That was a requirement that the government also placed. So how are we going to shut one injector off when you have 4 injectors slaved together, or all 8? Well, you do it by sequential fuel injection, which means you now monitor top dead center and you can tell through the crankshaft rotation which cylinder is misfiring, and that's what OBD2 did. So in order for this cylinder misfire detection to work and properly, we need to wire the engine differently. Now, GM splits the engine to bank 1 and bank 2. Bank 1 is the driver's side, bank 2 is the passenger side, at least on the LS series V8 engines. And they share basically powers and grounds. They have their own power distribution circuit and they have their own ground distribution circuit, and they are separate from the opposite bank. If they weren't separate from the opposite bank and you had a failure, then all eight injectors would go and you're done. You're going to stop. By separating the power distribution, separating the ground distribution, going to sequential fuel injection, which means the computer is monitoring each cylinder individually, is controlling spark on each cylinder individually, it's controlling the fuel delivery on each cylinder individually. You're almost in a way running 8 individual single cylinder engines, and with the proper hardware, network, and software/firmware, you can now go into limp modes and failure modes where you shut an injector off and you're not gross polluting and you're still driving home. Now, one of the problems with modern engine swaps, and not just engine swaps, but harnesses that some manufacturers offer, is they don't follow these manufacturer rules. Now, in the old days, when I started doing swaps back in the late 70s, early 80s, there were like 5 things that could go wrong with the vehicle. You had a carburetor, coil, spark plugs could foul. Yeah, there was a handful of things that can go wrong, and in general, if a distributor failed, you were going to stop. Distributors are pretty reliable though, even the HEIs. Now in a modern engine, there's a lot more things to fail. Since we're running crank sensors, cam sensors, fuel injectors, variable valve timing, cylinder displacement, or variable cylinder displacement, which is MDS, DOD, AFM, there's a lot of stuff that can go wrong. So proper monitoring of these systems is now the responsibility of onboard monitors, and the US EPA certifies the emissions portion of these monitors, and that includes the transmission. It's the whole driveline. It's not just the engine, and the failure modes. So if you were to have an injector to go bad, if you were to have a ground circuit go bad, or a power distribution circuit, an injector shorted out and you lost that injector, these failure modes and limp modes are designed to get you home and designed to not gross pollute. So it's very important that the harness and the wiring match the software and the calibration, not only to remain emissions compliant, but so you don't stop. If we had run all the injectors, let's say, off of one fuse, and that fuse went bad, you stop. Same thing with the coils. The manufacturer has divided up power distribution for input sensors, outputs. An input would be an O2 sensor. That is one of the most critical sensors on the vehicle. Now with the modern O2 sensors being ultra fast, running upstream, downstream, which means one in front of the cat, one behind the cat. Some of them run aspirated cats, which means they put oxygen in it. The cat basically converts bad gases into good gases by combining things with oxygen to make H2O and CO2 rather than CO and HC and NOx. There's NOx converters that require temperature to break up the nitrides of oxygen that are created under high cylinder pressure and temperatures. So there's all this stuff going on, and the manufacturers know this, and most of you probably don't. So when you do go into a failure mode, let's say you do lose an injector, they're going to shut if you lose an injector, it shorts out the fuse on, let's say, bank 1. You're going to keep driving on bank 2. The computer's going to shut off everything on bank 1 so that you're not gross polluting, and try to keep the engine running so that you can get where you need to go. And it's a whole orchestra that is coordinated between the harness, the modules, and the calibrations. So playing with that like we did in the old days. When I would put a small block Chevy in a Vega or a Pinto, it was pretty simple. It was 2 or 3 wires. You had your ignition, which was full 12 volts on an HEI type ignition, or you ran it through a resistor on an earlier non-HEI electronic ignition. And you had your spark plugs, which is the secondary part of the ignition system, primary and secondary ignition. Carburetor, no electronics at all unless you had an idle up solenoid. So it was really simple, and you could pretty much stay on the road even if you had a failure in the middle of nowhere. You could take a carburetor apart and fix a stuck float. You could take a distributor apart and figure out what happened. You know, if the points were stuck or whatever, and you're on the road. So it's the same thing with a modern engine. By going to all these electronics, by the late 80s and early 90s, these things became a mess. The vacuum hoses everywhere, solenoids, aspirator solenoids. I remember some of the Hyundais having just banks of air solenoids to lean out the engine. And when they did have lean crews back then to do secondary air pulse, which means it's not a pump air, it's a pulse air system. Secondary air is air that goes into the exhaust. It doesn't go in through the intake. That would be primary air. So it was kind of a mess. And if you look at a vehicle from the mid 80s, they were a nightmare to work on. Now in the 90s, they really cleaned things up. We're now running heated O2s, closed loop at idle, reduced the wiring count, reduced the oxygen. The oxygen sensors became very sensitive through low reference. And here's another very critical part about the modern power distribution system.